Hi, in this video we are going to give an introduction to alignments. Here in my Civil 3D I have opened the drawing called Introduction to Alignment. In my Civil 3D window you will see alignment in Civil 3D. Alignment is the horizontal component of a Civil 3D object. In this alignment you have line, curves and spirals. This red one shows the tangent or line and the green color one shows the spiral and the blue color one shows the curve. So alignments are mostly generated from lines, curves or spirals or a combination of these things. You have two places in Civil 3D where you can find alignments. In your Prospector, you have two places. One place is alignment, the other place is sides. At both of these locations, you have centerline alignments. If you expand this, you can see centerline alignments. Also, if you have a site created, you can see these alignments have same thing, both have same components. In site design, when you are working with parcels, we usually use sides. So in that we have special use of alignments to create parcels. So that's why we are using alignments in sides. In general, we are using alignments in the alignment category in Civil 3D. So if you expand the centerline alignments, you will see some other components. Here I have my alignment drawn in my Civil 3D. If you click this, you can see the name of the alignment as alignment DCL. Same thing is noted here, DCL. If you further drop down this DCL, you can see some other four components. They are related to superelevation view, profiles, profile view and sample line groups. Once they are added to the alignment, they will show up here. So apart from that, you have 5 categories of centerline alignments. They are centerline alignments, offset alignments, curve return alignments, rail alignments, and finally miscellaneous alignments. Centerline alignments are used in road design mainly as road centerlines. Offset alignments are used as the edge of pavement or tie edge in offset alignments. Then curve return alignments are used in intersection design, and rail alignments are used in railway design, and finally miscellaneous alignments are used in utility design. That means pipe networks or other utilities. You can use that alignment type as your alignment type. So that is the basic introduction to alignments. In the next video we will look further into alignments. Hi, in this video we are going to learn about alignment styles. So you can see an alignment in my drawing. So this is one way of showing or displaying the alignment. We call this the alignment style, the way you set your alignment to see to others. To change this style, we select this style and right click and go to alignment properties, and in your information tab you have object style. You can change this style so that you can change the view of this alignment. Now I select basic style and press apply. You can see this become kind of a white line. So if you go to existing one and press apply, you can see it is becoming complete red. So if you use intersection basic, again you will see it is kind of a white line. If you go to proposed, it is kind of a blue line, green line. So these are the various styles we can adopt in our alignment. So it can be used to show the alignment in various ways, or to modify or to separate the various alignment styles in your drawing. So if you have centerline alignment and a drain alignment, you can use separate styles to view them separately. So here I will use layout as my style and press OK. So in my style it is set to use, red for tangents, green for spirals, and blue for curves. So that is how this style is created. So if you wish to change these colors, you can select the alignment, then go to edit alignment style, and in your display tab you can change these colors so that it gives you other type of display or some other display than this display to view your alignment. So when you are doing, if you are doing that, it is better to do it to a new drawing or copy of the style. That can be done by this way. You select the alignment, go to alignment properties. Here you have the layout style. So you create a copy of this style, go to copy current selection, then you have a layout copy. So if you need to change these things, you change the things in your copy. So also you can change the name and description of that copy also. So I will not be doing that, but that is an idea how to use that. Again, some other thing is adding alignment markers. So I select this object style, I click here and go to edit current selection instead of copy current selection. We have a tab called markers. So currently I have a marker only for PI point. So you can add several markers, begin alignment, end alignment. So according to your need you can add markers. Currently I have a marker at the PI point. Let us say we change this marker to sidewalk and see what happens here. Click OK. Now my marker is according to sidewalk style. So if you need to change this, you select this point and right click, go to edit alignment style, and in the markers you can change the marker style as PI point. Click OK. Right, this is that style. So that is how to change the alignment style, and that is about alignment style. If you need to change these things, you better to have a copy of the alignment style and do the changes in that, because it may save your default styles. If you change the default styles, it might be a problem to get it back, because you cannot go back to the initial stage once you change the alignment, default alignment style, because maybe you cannot remember all the changes you did into that style. So better to have a copy of the alignment styles when you are going to change the styles. That is about alignment styles. Hi, in this short video we are going to look at how to add alignment labels. We are dealing with alignment labels in depth in a later video. So in this video I will tell you how to set alignment labels at once or in a quick manner until we learn them in depth in a future video. To do that, I have to select this alignment, then I right click, go to edit alignment labels, then from the import label set I select major and minor only, actually major, minor and geometry points, then I select OK. So it will let me to add these kind of labels, major station, minor station and geometry points. So I click OK, then I see my labels are added here. My labels are added in 20-meter intervals. I have minor labels, not out the label, only the tick mark at 10-meter intervals. So that is about how to add alignment labels. Actually this is not a label, this is a label set. So this is a quick start for labels, but we will be discussing it in depth in a future video. Hi, in this video we are going to look at how to create alignment from object. There are several ways to create alignment. One method is create alignment from object. When you consider about objects, there are polylines, lines and arcs to create alignment. So in my left I have a polyline, in my right I have a collection of lines and arcs. So I will create an alignment from these objects. Actually I will create two alignments because I have one set of polyline here and one set of line and arcs here. So I can create two alignments. So to do that, in my home tab, create design panel, I go to alignment. In the alignment drop down, I have create alignment from objects. I click it. So in the command bar, it is asking select the first line, arc or polyline or href. So since we have a polyline here, I select this. Then I press enter, or else you can right click. Then it is asking whether this alignment is going south to north. If it is so, you press enter, otherwise you press R to reverse the direction. Now I am assuming that this is going south to north, so I press enter to accept the direction. Then it is giving me a window to select the alignment style and other things for this alignment. In the first one, you can have a name for your alignment. Then you have the alignment type. Usually we select it as centerline. And here you have the start station. Most of the times we start our alignments from 0. So if it is other than 0, you have to type this station here. Then you have something called side. We don't much consider about that this stage. Then you have the alignment style. I will use my alignment style as layout. Then I set my alignment label set to no labels. Then I can tell Civil 3D to add curves between tangents. That means if you have straight section, this option will automatically add curves between those tangents or straight sections. For the moment I will uncheck it. Then this option is to erase existing entities. That means when we create the alignment, whether we want to retain the polyline or erase the polyline, we will set this to erase the polyline. So when the alignment is created, your polyline will no longer be there, it will be deleted. I press OK, then you will see the alignment created. Here you can see now your alignment is created. The lines appear as in red and the curves appear in blue, and the extension of the tangents appear in white, but they are not a part of the alignment, they are virtual extension lines. So if you wish to delete or make them invisible, you can do it like this. You select the alignment, then go to alignment properties from here and go to point of intersection tab. Then at here you select do not display implied point of intersection. That's how to remove the point of intersection nodes from Civil 3D alignments. Now next I will create another alignment from these polylines, actually lines and arcs. Now they are set of lines and arcs, they are not connected, they are separated. So when you are creating the alignment, we have to select them one by one. Right, now I am going to create the alignment from object as before. I select the create alignment from object, then I select these entities one by one, and after selecting all the entities I press enter. Then it is asking the direction of that alignment as before. If it is this direction, you press enter. If the other way, you will press R to reverse the direction. This time I will press R to reverse the direction. In my keyboard I press R and press enter. Then the direction reversed, but you will not see that, it will be reversed anyway. Now these are the options we have seen in the previous alignment creation also. This time also I uncheck this option and make this option checked and click OK. Then you will see another alignment created from the line and arcs. If I set my cursor here, you will see the station value at the bottom of this tooltip. You can see this is the direction where it increases the station value. So we will be learning them under alignment labels, but for the moment you know that alignment is increasing from this side to this side as we said. So that is about create alignment from object. Hi, in this video we are going to look at how to create alignment using alignment creation tools. But when you are creating alignment from alignment creation tools, there are several things to be learned. They are alignment creation tools with fixed entities, free entities and floating entities. In this video what we are learning is alignment creation tools through fixed entities. So in this case we are not going to create complete alignments, but we are creating parts of alignment to understand each entity type, fixed, free and floating entities. So to go to alignment creation, I am using my home tab, create design panel. This time I will use alignment creation tools. I click that, then a window will be appeared. So as before, you can set your name and start station, alignment style, label style. You can set these things. I will change the alignment style to layout and I press enter. Press OK. Now a small layout window will be appeared, that is alignment layout tools. So here we can draw our alignment. As we learned earlier, as I told earlier, in this video we are learning how to create alignment from fixed entities. Fixed entity means they have no constraint from others. They are fixed. They stay as it is. So I have three objects here. One is a straight line, one is a curve, the other one is also a curve. So I will first create an fixed line through this object. To do that, I click here, select fixed line, 2 points. Then I zoom here. If you have turned on your end object snap, it will come here. Otherwise it is okay, you can press near that end. Then it is asking for the second point. I press the end of this line. Now my fixed entity, first fixed entity, which is a fixed line with 2 points, is created. Then I press escape. Now I will create a fixed curve here. To do that, I go here. Here I have curves, and I select fixed curve 3 point. I select that. First I select the end point, and then I select the midpoint. So I have turned on my nearest object snap here. So if you haven't turned on your nearest object snap, you can use object snap override to do this task. For that, press shift key on your keyboard, then right click. On the menu that appears, select nearest. Then you can select the nearest point. Then I will click the end point of this curve or the arc to complete the creation of that alignment entity. Now I have a straight line, then I have a curve. They are fixed entities because they don't depend on each other. That means this straight line don't depend on other entities. This curve don't depend on other entities. So we will be discussing in detail about these things in later videos. Now I will press escape on my keyboard to end that command. Then here I will create another fixed curve. This time I will use this option. Here under curve drop down, more fixed curves, fixed curve 2 point and radius, this option. So to do that, I need to know this radius value. So I press escape to end here. Then I want to know this radius. I click here and go to properties, and it will tell me what is the radius. It is 1106.47. So I copy that radius and go here and 2 point radius. Select this end point. It is asking the radius value. I press paste here for that value. Otherwise you can type that value also. Then it is asking the curve direction. So if it is going this way, it is clockwise. If it is going this way, it is anti-clockwise. So since the alignment is going this way, my direction would be clockwise. So I press enter to accept that. Then it is asking for my endpoints. I select it and I press enter to end the command. So That is how to create fixed entities. There are so many ways to create fixed entities. Here you have 3 methods, and also here you have few methods. You can learn them on your own if you wish. Otherwise you can use these options always to create fixed entities. In the next video we will see how to create floating entities for your alignment. Hi, in this video we are going to look at another method or another part of alignment creation tools, that is floating entities. Floating entity means it is something different from the fixed entities. In fixed entities we don't have any constraints because they are fixed. They don't depend on other entities. In case of floating entities, one side of the floating entity depends on another entity, mainly a fixed entity or another floating entity. That means when it is changed, or when a floating entity is going to change, it depends on another entity when it is changing. We will see how to do that. So I have already created the alignment here. Now I am going to add the floating entity here. Now this alignment is created from alignment creation tools. This is a fixed line. So to add the floating entity parts, I need the alignment creation toolbar that can be obtained by selecting alignment and right clicking, then edit alignment geometry. If accidentally you close this window, you can get it back by selecting the relevant alignment and right click and go by going to edit alignment geometry. Now I am going to add the floating entity. To do that, I go to this curve option because I am going to add a curve to this alignment. Before that, I am going to try to find out which direction this alignment is going. I place my cursor here. It is 82 at the bottom, you can see. Then it is 400. The station is 400 at the bottom, so it is going this way. So I am going to add a curve here. I select this option. Then I am going to this option, floating curve from entity, radius, through point. I select this. Then it is asking select entity to attach to. I select this entity, which is a fixed entity. Then it is asking the radius. I will type my radius as 2000, a fairly large radius. Then it is asking whether your curve solution is less than or greater than 180. Most of the times, that means about 99% of the times, we get less than 180 option. So I press less than 180. Then it is asking where is your end point. So while I am going to select my end point, you will see my alignment is moving, but it is always maintaining a tangency with the fixed entity. That is why we call this as a floating entity. It is floating with that connection entity. So I press here to end my entity. So I have a floating entity to this one. Now my floating curve has finished. I press enter. Then I am going to add another floating entity to this. The first one what we added was floating curve from entity, radius, through point. From entity means it is not going to be at the end of that entity. It is maintaining the direction only, but it can be anywhere from that entity. This time we are going to this option, from entity end through point. That means this option will be continued from the end of that particular entity. That means when you select this one, it is asking select entity to attach to. I select this one, then it will go from this end point. It will start my other curve from this end point. So through point means I can select where to stop this curve. So I will stop this curve here. Some additional thing I will have to tell here. Before that I press escape. If you have a curve like this and another curve like this, we call them reverse curves. If you have a curve that is going in the same direction like this one, you call it a compound curve. This time this is a reverse curve. Now I am going to add a floating line. So far we have added floating curves. Now I am going to add a floating line to this curve. To do that, I select here, select this drop down, then I select floating line from curve through point. I select that option. Then it is asking in the command line select entity to attach to. I select this curve. Then I can select a point where my line needs to be ended. Right, that is about floating lines and floating curves, or in other words, that is about floating entities. In the next video we will be discussing about free entities. Hi, in this video we are going to look at free entities. So far we have discussed fixed entities and floating entities. This time we are going to look at free entities. In free entities, what is the difference? The difference from the previous two is the free entities are constrained by both sides. That means it depends on two sides, or it depends on the parameters of both straight or curved sections either side of that entity. We will look how it is. I select this alignment, then I go to edit alignment geometry. You can go it from here, or also you can go it from here. Now I am going to have a free curve here. I select this curve drop down. I use free curve fillet between two entities through point. Also you can use radius option also. I use this one. Then I select my first entity at the left and my second entity at the right, and I can select where to stop. I will stop somewhere here because I am using the through point option. I will stop here. Then I press enter to end the command. We call this free entity because this curve depends on both these two straights. That is why we call it a free entity. It is constrained by two other entities either side of that. Even though we call it free, it is not actually free. It is depending on two other entities. Now we have seen how to create a free entity from a through point option. Also you can use radius option to create a free curve fillet. Then I will do a free line here. To do that, I go to this line options and use this free line between two curves option. This is the only option we have for free lines. The free lines can be drawn between two curves only. So I select this option. As the first entity, I select my curve at the left. For the next entity, I select my curve at the right. Then a free line will be drawn. So that is about free entities. So when you are creating an alignment, you can use all these types. That means so far we have learned fixed entities, floating entities and free entities. You can use all these types to create your alignment. Hi, in this video we are going to practice all the alignment creation methods we learned in the previous videos. That means alignment creation tool methods with fixed, free and floating entities. In my drawing I have a line created and I have given few steps so that you can use these steps to create your alignment. So we will be creating the alignment using these steps. So before doing that, I want you to set your object snaps in such a way that it will not disturb you when creating the alignment, as well as it will help you to create the alignment. To do that, press shift key on your keyboard. While pressing shift key, right click on your mouse button and go to object snap settings or snap settings. Then make sure only endpoint and nearest are turned on. I have intersection turned on. I will uncheck that one. I have only nearest and endpoint turned on. Then I click OK. Then I go to create alignment from alignment creation tools. Then I accept the default. For the moment I will turn off the labels. Anyway, I will make the labels on and I click OK. Then my first option is to start the alignment with fixed line 2 points, these 2 points. So I go here, fixed line 2 points. This is my first endpoint and this is my second endpoint. The snapping helps me to find out the correct endpoint. Then I click here, then press enter. You can see my stationing also appears. Then my second point is fixed curve from entity end through point. So you have curve here. This is the one we have to find, fixed curve from entity end through point. So the curve will be created from the end of this entity, and the true point will be the end of this curve. Now we can see the stationing continues. Now our number 3 is here. It is a fixed curve 3 point. It's a fixed curve 3 point. Then number 4 is free line between two curves. Free line, you can have it here. You select the first entity as, and now it is asking for the second entity. Before that I have to do something. I will turn off this tangent lines. That is why it is not coming. I turn off that. Now I go to that command. First I select this one, then I select this one. You can see the line created. Then I press escape. You can see the stationing continues. Then my number 50 is floating line from curve through point. Here floating line from curve through point, this one. Click this one and my alignment will pass through this point, so I press enter. Then my number 6 is floating curve from entity end through point. Here floating curve from entity end through point. My end point is here and my true point is somewhere here. Then my number 7 is floating curve from entity radius through point. Here I have floating curves here from entity radius through point. So I am selecting my first entity. Then it is asking for my radius. Radius is given as 150 here. So I type 150 here. Then it is asking for the solution angle. Usually it is coming as less than 180. This curve is a reverse curve. It is asking whether the curve is compound or reverse. This is a reverse curve, so I type R to accept the reverse curve. Then it is asking to specify the end point, so your end point will be here. Then number 8 is floating line from curve through point. This one earlier we did also. Select this one and go to the endpoint here. Then number 9, it is a fairly new command, floating curve from entity through point direction at point. So it is here, floating curve from entity through point direction at point. I select this option and it is coming from this one, and this is the end point of the curve, and direction is given by the direction of this line. So I have to select a point along this line. My nearest object snap helped me to select that line, so I click this and press enter. So my curve appears as like this. Finally I go with floating line from curve through point. We did that one earlier also, so we did that earlier also, so that command is highlighted here. We don't need to go and select from here, it is already highlighted. You can see here from this check mark. So instead of going this drop down, we click here. Then I click this endpoint of the curve and click the endpoint of this line to complete the alignment. So that is a complete practice of the alignment creation tools we have learned so far. So you can practice on your own and get more experience on this. That is about alignment creation tools with Civil 3D alignment creation. In this video, we are going to look at how to create alignment from tangent and curves. We already seen alignment creation tools and creating alignment with alignment creation tools from fixed entities, free entities and floating entities. But here what we are looking at is an extension of alignment creation tools, but it will automatically create tangents and curves when we are drawing the alignment. So to do that, we go as usual from here alignment creation tools, and you give a name here. Then you can set a style here. I set layout style for the moment, and I click OK. So before doing anything, I have to show these things to you. From this option you can draw only tangent, and from this option you can draw tangent with curves. When the curves are incorporated, you can set the curve radius from here, curve and spiral settings. If I click here, you have my default radius is 200. So when we are creating automatic curves, the radius would be 200 here. So I click OK. So here I would go with this option for this example, and also you can try with this one because it has no curves. So I click here, then it is asking my starting point. I click here, then it is asking my next point. So I zoom a bit and click somewhere here. Then it is asking for the next point. So when I click for the next point, you will see an automatic curve is adding. An automatic curve is adding. So I click here. Again, I go to the other side. You can see an automatic curve is adding. And also you can move somewhere again outside. So now you can see how it works. That is about creating alignment from tangent with curves. Also you can try tangents without curves. I press enter to end the command. So that is about creating alignment from tangents with curves. It is automatic curves where we have a pre-specified radius for the curve. In this video we are going to look at how to add spirals to our alignment. This is some special part in Civil 3D alignments, adding spirals, because so far we have learned alignment tangents and curves, but spirals is also one of the important part of alignments. A spiral means a curve, but if you consider a curve, you have a known radius for that curve, but if you consider a spiral, it has a changing radius. When you have a spiral, its radius changes from infinity. Infinity means a straight section to the desired curve value. So the radius changes from infinity to a number which we know, or a radius which we know. First we will add a spiral curve to this alignment. I select this alignment. This is my alignment direction. Even though the labels are not on, I will turn on the labels for easy clarification, so that you know now my alignment is going from this side to this side. Then I select my alignment and go to floating curve with spiral. It is somewhere here, floating curve with spiral. So I will use floating curve spiral from entity radius through point option. I select this entity and my radius I will type it as 650. Then it is asking for the spiral length. Let us say it is 40 meters. Now so curve solution is less than 180. Then it is asking a true point where my radius have to stop. So you have this curve as well as my spiral. Then I press enter so that the alignment stationing continues. So you should see the labels here. This is 1037 and this is 1077. That means you have 40 meters spiral and this is 650 radius curve. Then I am going to add another curve here. Sorry, I am going to add a line with a spiral. So I select this option, floating line with spiral from curve and through point. I select here, then I press this curve. It is asking my spiral length. As the same previous one, I select 40 as my spiral length. Then it is asking for a through point where I need the line to go. I select this point and press enter. You can see my alignment continues and another spiral is added here. Then I will add a spiral to this point, two spirals before the start and end of the before the end. So I go here, free spiral curve spiral between two entities option. As the first entity, I select my left side of that entity and then the right side entity. It is asking the solution angle. It will be less than 180. It is asking for my radius. Let us say it is 600 meters. Then it is asking my spiral in length. I type it as 40. These spiral lengths can be calculated using highway design or highway engineering theories. So you have to select the proper value for these spiral lengths. I am just arbitrarily typing 40, but you have in designing you have to get the correct value for these spirals as well as this radius also. So I press 40, select 40 as my spiral in length. Then it is asking what is my spiral out length. I use 40 for the same as in the previous in spiral. So our spiral out length will be also 40 meters. Now I press enter to end the command. You can see another two spirals to the start and end of the curve appeared. Now that was a curve with spirals between two entities. So that's about adding spirals to your alignment. So you will be using them someday when you are designing with Civil 3D alignments. So there are so many options to practice. You can use these options to practice and see what will be done by these various options. So that's about use of spirals in Civil 3D alignments.
Hi, in this video I am going to tell you how to create alignment from an existing alignment. That means we have an alignment. Using that alignment we create a new alignment. For example, we say we will have a 100 kilometer length alignment, but we are asked to design 20 kilometers of that road. Let us say we need to design from kilometer 50 to kilometer 70. So it is a burden to keep 100 kilometers road in your design file. So in that case we will extract 20 kilometers portion of that 100 kilometer road for our design purpose. In that scenario you can use create alignment from existing alignment tool to create your alignment. Here I have my alignment. Using this alignment, I will create another alignment which is a lesser length than the original alignment. Before doing that, you will see this kind of tangent extensions. So if you wish to remove them, you can do it like this. You select the alignment, go to alignment properties, and in the point of intersection, you click do not display implied point of intersection. Then these lines will be disappeared. I press escape now. Now I am going to create the alignment we are talking about. Create alignment from existing alignment. From the ribbon home tab, I move to alignment and click the drop down. I find at the bottom create alignment from existing alignment. I click that one. Then in the command bar it is asking select an alignment or press enter to select from the list. So I select my alignment here. Then it is asking what is the starting point. Let us say I am starting from 200, and you can see now my new alignment continues. So let us say I stop the alignment at 1 kilometer point. So once you click here, you have to click finish here. So the alignment will be created. Then you will see some kind of window popping out, that is for alignment creation. So you can give a name here, and these parameters as usual you can set the parameters. I set here as layout and click OK. So you will see another alignment has come here, but you still don't see it properly because you have both alignments. So I click this one, which is outer side of the alignment we created earlier, and then I delete it. Then you will see the other alignment, that is starting from 200 and ending at 1000. Since we have started the alignment from 200 and ended the alignment from 1 kilometer, it is taken the same stations for the new alignment. So if you need to change these stations, you can change it in some other way. I will tell you that way in a later video. For now, that is how to create an alignment from an existing alignment.
Hi, in this video we are going to see how to modify the alignment. So far we have learned how to create the alignment. In this video what we are doing is how to modify the alignment. Here I have an alignment. If I select this alignment, you can see the name is alignment tree. First we will do something like this. To edit your alignment, you have to go to alignment geometry editor. It is on the ribbon, or you can right click and go to edit alignment geometry. This toolbar layout tools will appear. First what I do is I will add a PI point. A PI point means a point where the tangent changes in direction. I click here. It is asking pick near PI to insert. So I will add a PI point here. You can see my alignment now goes like this. Then I press escape to accept that. Then I am going to add a curve here because this transition is not smooth. It suddenly changes the direction. to give a smooth transition, I will add a curve here. This is not modifying alignment, this is adding something to alignment. So I go here, I use this option, free curve fillet between two entities through point. I select it, then I press my left side entity and the right side entity, and my true point will be something like this. Then I press enter to finish the command. So I can see I have a curve like this. Then what I am going to do is delete an entity. Delete an entity. So it is here, delete an entity, delete sub entity actually. So I will delete the one I created. I select this one and see. Then what happens is it delete the curve and go to the initial state. Once I press enter, you can see my PI point comes here. Initially it was with a curve, now there is no curve, only we have a PI point. So if you like to delete some other parts, you can click here and click this part to delete. So I won't delete any more entities. So next what I do is I will delete a PI point. We have only one PI point here. This one we just created that. So I delete this PI. If you want to delete a PI, you have to use this option. I select this one and then I press here so that it will be deleted. You can see the PI point deleted. So that is about deleting PI. Then I come to here. You can see convert AutoCAD line or arc to a Civil 3D alignment entity. If I go to the end point of my alignment, you can see there is a line. So I select it, it shows it is a line. So what I do is I am converting this line to a Civil 3D tangent or fixed 2-point line. So to do that, I have to click this one, convert AutoCAD line or arc to entity. I select this one, then I select this line, then I press enter. Now this entity was added, but you cannot see the stationing is not continuing. So there may be some problem here. What is that? Your stationing was not continuing because the direction of that line is from this side to this side. Your alignment stationing goes from this side to this side or left to right, but this entity was from right to left. So your alignment cannot continue from this point. So what we have to do is we have to reverse this entity. Then it will go left to right and the stationing will also be continued. So to do that, I click here, reverse sub-entity direction. I click this one, then it is asking select fixed line or curve to reverse. You have to remember that you can reverse the direction only for fixed entities. You cannot reverse the direction of free and floating entities because they are depending on other entities. Fixed entities are not depending on other entities, so you can change the direction as you wish, but for floating and free entities you cannot reverse the direction. So this is a fixed line, so we are going to reverse it. So it is asking select the fixed line to or curve to reverse. I select this line, then it says fixed entity reverse, then I press enter. You can see my stationing also continued to the other side because the entity reversed. Then I am going to move to this one, pick sub entity editor. Let's see what we can do from here. I click this one. You can see a small menu, small window appears. So Then it is asking select subentity. Select subentity means you have to select a curve, spiral or tangent. I will select this one. It shows me the data related to here. It shows me the length, it shows me the direction, it shows me the pass-through point, which is here. Then it shows me what kind of entity is that. Drag it to be more visual. So it is a fixed entity and the parameter constraint is true. So this data is available here. If I select this curve, it is a free entity. Its radius is 550 and some other data related to it. So if you need to change this radius, you can do it by just typing it here. Let us say we are going to have 600 meter radius. You can see what happens here. It automatically updates for 600. If you say 800, it automatically updates. You saw that. So you can easily modify the alignment from this big subentity editor. I'll select this one. This one also you can select, change the radius. If I go here, in this option you cannot change the radius. Why is that? That is because this entity is a fixed entity, so the radius is fixed. So if you need to change this, you have to make this true, false actually. Then you will be allowed to change this curve radius. Let us say we change this to 250. Then what happens here and here? Once you change, you have a caution mark or warning sign at this ends. I press enter so that you can see it clearly. Now if I move my mouse here or my cursor here, you see tangency violated. Tangency violated. That means this curve is not tangent anymore to this line. And also it says this curve is not tangent to this one. So how to resolve this? If you are designing road alignments, it's very essential to have tangent alignments to have, so that you have a smooth alignment. Now we are going to smooth this alignment. Currently it is not smooth. The tangency is violated. It happened because we changed the radius. So how to maintain this tangent? We can do it like this. We go to pick subentity editor. Now my window is appearing. Then I press here again. Then I say this curve to, I ask this curve to follow the previous floating. Floating means this line. Constrained by the previous, it becomes a floating one once you set this option. You'll see what happens. Now the curve changes and make it tangent to this line. That's for this side, and for this side you select this curve because you can't make it tangent to that side. It will create problems. It's better to tangent always. It's better to make tangency always to the previous entities, so that less problems. So I select this pick subentity editor. Then I select this one. It is also a fixed curve. I ask it to follow the previous one. Then you can see it is made tangent and it create a problem in the other side. So I press enter and I will show how to solve this problem without going to this option. I go here and close here. Then I go to alignment grid view here. It also shows that I have non-tangent option here. When I select my entity, it highlights. If I select this curve, this highlights. So this is same as using the pick sub-entities, we are using the alignment grid view, so we can make it floating to the previous one from this point. If you click here, you can make it floating. Now all the things are fine. So if you like to change the radius at once, you can change them from here. That is an easy way. If some parameter is locked, you can unlock from here. Here, if I lock this one, it doesn't happen anything, but if this radius is locked, you can unlock it through here. So if I change this to pass through, you can have a pass through point. So that is kind of advanced, but it's better to have radius in this point, so you can change the radius and make any modifications. So that is about how to change the radius and parameters from alignment grid view. But make sure when you are changing the parameters, you have to ensure that your alignment is at the correct position. Sometimes when you are doing the changes, your alignment goes here and there without your intention, so you have to pay close attention to that. Now sometimes there may be a situation that when you click this pick sub-entity editor, you can't get it. It is not coming. Even though you select this one, that window is not coming. In that case, what you have to do is you have to press this one once, and you have to press it again. Then this window will come. Then if you select a curve, it will give you the directions and radius and all those data where you can edit these things. If somehow this data is not viewable, you have minimized these things. So expand them, you have to click here. If it is minimized, you can't see any data. You can see them by expanding the data. So that is about modifying alignment. So you can do any modifications to alignments using these tools now. And also, as undo option, I haven't told you, these two you can use to undo and redo only the alignment based options. That means if you change the alignment radius, it will undo the radius only. It will not undo the AutoCAD based commands, but it will undo the alignment based things from here, these two options. So that's about modifying alignments. Hi, in this video what we are going to look at is something called criteria based design. If you are working as a design engineer or highway design or with a highway design team, you may know that your alignments are designing according to a design criteria or design guidelines. Some of these design guidelines are AASHTO, Crossroads, and you have UK guidelines, Indian guidelines. So when you are designing the alignment, you have to follow these guidelines. In Civil 3D, it helps us to specify these design criteria files into our drawing and check whether our alignments are in line with the design guidelines. So in this video, we are checking our alignment according to Civil 3D inbuilt design guidelines. It is based on AASHTO. So I select the alignment for that. Then I go to alignment properties. In my design criteria tab, first I have to specify a design speed, because all the design criteria are based on design speeds. So I select this one. Then I have a design speed of 100 kilometers per hour. It is giving me as the default. And if you need to change it, you can select here and change it. So if you have several design speeds for several sections of the roads, you can incorporate it from here, several criteria. But for the moment, we will deal with this 100 kilometers per hour throughout this road. Then you have to specify this use criteria based design. So it will allow you to set a design criteria file where your alignment will be checked with. So to set this one, we select this one, and I am going to check my alignment against this criteria, metric 2011 roadway design standard. I click open, so it will be set. Then my minimum radius table would be Astro 2011 with 6% Emax, and these two related to super elevation. We won't be talking it here. And I click OK. You will see nothing happens. If nothing happens means sometimes your alignment is okay with the current design guidelines. Anyway, we have to check it. To do that, I click this one. Then I go to geometry editor, and I go to pick sub-entity editor. I click the sub-entity, and it shows me the constraint is for the radius. The constraint is 437. If your radius is less than 437, it violates the criteria. So let's click this and see what happens. We will make this radius less than 437. To do that, I change this to false. Then I type 400 and press enter. It shows a violation here, minimum radius table. There's a violation. I close it here and then I escape. But until I go there, you can't. Until I go here, I don't know my radius is not okay. So this happens to us sometimes because there's a layer turned off. That is why it is not showing us. So to view that layer, I click this one and select the alignment and right click, go to edit alignment style. My display tab, I have to turn on this warning symbol. It is not turned on up to this point, so we haven't seen any errors in that alignment. So once I click OK, you will see we have so many errors in my alignment. These warning symbols mean there is some error. When you click the cursor here, it says design check is violated. So if I go here and select this spiral, it is saying this spiral length is violated this criteria. So it should be less than 46, greater than 46, but there is some other violation here. So you have to inspect the drawing to find that. Again, I am not going to go to more detail. Then here we have this one. This radius violation here. So I put my cursor here, it will show me current radius is 400 and minimum radius should be 437. So that is about criteria based design. So if you design the alignment with criteria set into your alignment, it will show you whenever you violate the designs with a warning sign. So I hope that you have some kind of idea about criteria based design. Hi, in this video what we are going to do is adding a mask to an alignment. So if you are designing this road, that means if I click here alignment 3, this road, which is alignment 5, would be disturbing. If you design this road, this alignment would be disturbing you because it is crossing you. You have an entity crossing your alignment, so it is bit disturbing. So by adding a mask, what we do is we are hiding the portion of this alignment in this region. We will see how to do that. I click this alignment because I have to hide this alignment, and I go to alignment properties from here, from the ribbon. Then I am going to the masking tab, that is at the third tab from the alignment properties window. Here you have a small button to add the masking region. You select this one, then it is asking where the first station for the masking. The alignment starts from this side and ends in this side, so I am trying to hide this region, so I click the start region, which is somewhere here. Then my second station for the region would be somewhere here, so it is showing that. So if you need to manually edit this one, you can type manually 210 and then 250 if you need rounded numbers. Otherwise you can keep the values as it is. Then you click apply. You will see this area will be hidden from the screen, so we can design this road very clearly without any disturbances. If you uncheck this option, that mask no longer will be there. The mask will be hidden and the alignment appears. If you apply the mask, the alignment will be hidden. So if you say lock start to lock end, hold alignment would be masked. That is how to use masking option in Civil 3D alignments. It will be useful when you are having disturbances from other alignments for your design. So that is about alignment masking. Video we are going to talk about the main or important feature on alignment, that is station equations. Station equations are very important, but it is used very rarely. But if there is a need for station equations, that would be very much helpful to you. So this is the scenario in station equations. Let us say this alignment 3 is designed by us. So it has been finalized. This profile has been finalized. For sections or section views, corridors, everything has been finalized. But in some stage of the project, we were informed that you have to change this alignment, not like this, but to be like this. Your radius would be not 550, your radius would be 200 here due to some external factor. So in that case, I have two alignments drawn. The second alignment is starting as the first alignment, same location, and it extends up this alignment station because somewhere here both alignments coincide with each other. Here it deviates from this point, the second alignment deviates, the alignment 6 deviates from the alignment 3, and again it joins with the alignment 3 and this station. So the problem here is at this station where these two deviates, both parameters are same. Station, offset, coordinates, both are same. But if you look at this location, your station is not equal because of the change in alignment. If you look at this endpoint of this alignment 6, these stations are not equal. They are shifted by some amount because of the alignment change. So if the shifting continues, because the change in alignment or shifting of the alignment continues throughout the project, so everything need to be, especially the section views, need to be updated according to that. If you have plotted the section views, so now the station of that section view would be changed, so you have to plot them again. Instead, what we do is we adding a station equation to this new modification, so that this station matches this station at this location. That means we change this station to 449.14. Let's see how to do that. You will get more understanding at that once we add the station equation. I select the alignment to do for adding the station equation. Then I go to alignment properties. Then I move on to station control tab where my station equation reside. I click station equation button. Then it is saying that you have adverse effect of editing this alignment or adding station equations, but I say I want to edit it. So it is asking where you need to change the station. This is where the two alignments coincide after the change. I select that point. At that point, my station ahead, station back, or the original station is 450.809. This one. My original station for the original alignment is 449.14. So I am telling that after this point you need to change your station as 449.140. So after this point, I click OK for that. After this point, alignment 6 thinks I have 449.14 station here. Then after that, it continues to label, thinking that this location is 449.14. I click OK. So you won't see anything here. No update comes here. But if you come to here, you get the same station. That means your stations have meshed. Initially there was a little shift between these two stations, but now those stations have matched. After this point, every station have matched. The change happened at this region only, so your change will be affected to this region only. Other parts will be same as the earlier parts. So that will reduce major change to your project. That is the use of station equation in Civil 3D. Hi, in this video we are going to look at negative stationing and reference points. In this alignment, you can see this alignment starts from 0 and going to the right side of my drawing. So the stationing goes from left to right. So you can see the alignment stationing is increasing from left to right. So let us assume in some stage we come across a point such that we have to change the start station of this alignment to this point. Currently this is 1 plus 100, so we need to change it to 0. So there may be some issue in the project and we have to change the start station. Let us assume we have to do that in the initial stage. So now we are going to change this 1 plus 100 station to 0. To do that, I click this alignment and go to alignment properties, and on the station control tab I select this pick reference point. I click it So it is giving me a warning that you are changing the alignment and it will critically affect your alignment. So we accept it by clicking OK. Then I use this point 1 plus 100 as my new reference point. Then you can see your start station becomes minus 1 plus 100 because you have 0 here, so it is going in the negative direction. If I press OK, you will see from this point the stationing goes as negative values and it is increasing to the other side, that means from right to left. Because of the reference point, my 0 becomes here and it increases to the left from towards right side. So that is how you deal with reference point and negative stationing. So if you need to change it back, you can do two things. One is go to alignment properties and select this reference point and select the initial reference point or the 0 station as before. That means in this case it is minus 1 plus 100. But if you don't like to change this reference point, you can type your start station as 1 plus 100. Then it will make your first station as 0 here. That is how to add reference point or change the reference point and dealing with negative station. Especially the negative stations occur when the alignment direction goes to the opposite side of the stationing. So here my alignment went to this way, but the negative stationing goes to the other way. That's about negative stationing and reference points. Hi, in this video we are going to look at how to create offset alignments. If you are familiar with AutoCAD, you know what is an offset means. Usually an offset means a line or a polyline which is at an equal distance or a parallel from an object. So when we create offset alignments, what we do is we create a parallel alignment to a base alignment. That means if you are going to create an offset alignment to this alignment, you have another parallel alignment to this alignment. To do that, you have to select the alignment. In your Prospector, you have something called actually in the ribbon you have something called offset alignment. You have to click that. Then a window will be appeared. So it is giving the base alignment name. This alignment is alignment 3. So it gives it. Then it gives a name. Automatically it gives a name for your offset alignment. And it is asking whether do you want that offset alignment from start of the alignment to end of the alignment, or if you need some other alignments, you can uncheck this option and select the required alignment from here or type the required alignment range from here. For this exercise I will continue from start to end. Then you can specify how many offsets to left and right. So here you have the incremental offset as 3 meter. That means you will have a offset alignment at 3 meter to the left, and for the right it should be another 3 meter. It will be more than 3 meter. That means it will be increment of 3 meter if you put more than one here. If you put 2 here, you will have 3 meter increments one after the other. So for this exercise I will place 3 meter offset and only one offset to the left and only one offset to the right. Then since it is an alignment, it is asking for alignment style. If you expand the drop down, you can see several styles. For the moment I will use offsets as the alignment style, and for the alignment label style I am not using any labels, because if you use labels it will be confusion with the main alignment label and the offset alignment labels. Then I am going to click OK. Then you will see two offset alignments appear either side of the main alignment. As you can see here, at 3 meter intervals you have two alignments. If you click this one, it will show offset alignment, alignment 3, right 3 meter offset, and to the left another 3 meter offset. So if you measure the distance, this would be 3 meters. The beautiful thing of offset alignment is they are dynamically linked to the main alignment. These offset alignments are dynamically connected with the main alignment. If you change any entity of this main alignment, the offset alignment will be automatically updated. The difference between offset in AutoCAD and difference in offset alignment in Civil 3D is Civil 3D's offset alignment is dynamically updated. So if I change the radius of this curve, you will see what happens. I change the radius by dragging this one out. You will see what happens. The offset alignments also shift as the main alignment, so it continues to maintain 3 meter offsets. Right, that's about offset alignment. So you have to wonder what kind of occasions we can use this one. Especially in road design, we are using these offset alignments. So this can be used to show the edge of the road, because usually in road design the edge of the road is at a constant width most of the cases. So you can use that offset alignment to show the edge of the road, because if we change any entity of the main alignment, it will automatically update. Instead of offset alignments, if you use the AutoCAD offset command, you have to change the offset line every time when you change the alignment. But if you use offset alignments, you don't have to change the offset alignment, because it automatically updates with the main alignment. So this link always be there until this main alignment stays here. If you delete this main alignment, this link won't be here, because this offset alignment is directly linked with the centerline alignment. If you delete this centerline alignment, these offset alignments will not be deleted, but they may not have a connection with the main alignment to dynamically update. You have to remember that one. That is about offset alignments. Hi, in this video we are going to look at how to add widening to an offset alignment. Usually when you create offset alignment in road projects, you usually end up with adding widening to them. If you consider the concept of widening in road construction or road project, the scenario is like this. So if this curve is a sharper curve, that means the radius is a lower value. When a heavy vehicle or a long vehicle goes through this path, if the curve is sharp, the rear wheels of that vehicle tend to go outside the road. So in that case, we are adding widening to the lane or In this case, we are adding widening to this offset alignment to avoid the tires going outside of the road. That is the concept of adding widening for offset alignment in road designing. So in this alignment, I am going to add widening to inner side of this curve. My alignment goes this side to this side. So we are going to add widening to this curve. The widening amount would be 1 meter. If you select this offset alignment, you will see my right side is 5 meter offset. So if it is 5 meter, if you have widening of 1 meter, that means altogether it would be 6 meters. So I am going to add widening from this point up to this point. So that means from start of the curve to end of the curve. To add widening, you have to select the offset alignment and go to add widening. Then in the command line, it is asking whether to create a new alignment for widening or to use the same alignment. So we are not going to create a new alignment, so we say no. Then it is asking what is the start station of the widening. We will select the start station of the curve as the start station of the widening and end station of this curve as the end station of widening. Then it is asking what is the offset for widening from the center line. That is the main thing. It is asking offset from the center line or the base alignment for the offset alignment. So the offset alignment is at 5 meter in offset. Now we are adding 1 meter widening. So altogether it would be 5 plus 1, 6 meter. So we type 6 meter here. Then you have this window open, that is the transition parameter for widening, because before the curve you have 5 meter offset, after the curve also you have 5 meter offset for the right side of the alignment, and in the middle of the alignment you have 6 meter at the right side with 1 meter widening. So there should be a transition of for the offset alignment to transit from 5 meter to 6 meter. Here it gives the transition method. If you click this, you have several methods: linear, curve, line, curve, 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 reverse curve, curve, reverse curve. You can use either of these options. For the moment I will use linear option, and for this one also I will use linear option. So my transition length I select as 25 meters. Then you can see this transition is created from this one to this one. This length would be 25 meters. So if you think, if sometimes when you change this one, the start station moves somewhere here, so then you have to manually set this to the required station again. This time it haven't changed, sometimes it happened. Now we have added a 1 meter widening to this alignment. Then we close it here. You can see we have a 1 meter widening offset alignment. That is how to add widening to offset alignment. Hi, in this video we are going to look at how to add some custom labels into our alignment. In my drawing, in this alignment, I have labels in 50 meter intervals. My major interval is 50 meter. Apart from that, I have minor ticks at 10 meter intervals, and also I have geometry point labels stated here. So what if we need a label somewhere here? So we don't know what is the exact label, what is the station that point. So to do that, I have to select my alignment. Then I have go to add labels. Then I go to at alignment labels, so I will be having a list here. Our feature is alignment, label type is station offset fixed point, and my station offset label style is station offset and coordinates, and the marker style is basic square. So let's see what happens here. I click add. So let us suppose we need a station value here. So it is giving me a station value. I press escape to end that command. Then I select this one, and from here I drag my label somewhere out from the alignment so that I can see it clearly. So you can see the data here, station offset label, station offset and coordinates. You can see station offset and the coordinates, and also the alignment label, and my marker style is basic square, so it is given as basic square. So you can change these things from here if you wish. Again we will see, now we have select a point on the alignment. We will see to add a point away from the alignment. So I go here, we have the same selected settings, and I go to add. So it is asking what is my alignment, since we have pressed escape in the previous command. So this is my alignment. So it is asking what is the point. Let us say I am clicking somewhere here. Then I press escape. So I drag this label so that I can see it clearly. So it is giving me the station value and the offset value and the coordinate. Also it gives me what side of the alignment it has. It is at the right side. The stationing is going this way, so this is my right side. So it gives me the station value, offset value, and the side of the offset, as well as the northing and easting values. Again we will see how to add single segment data here. So we have some data listed here, so you can see what happens once we add the single segment. I click to select the alignment. You can see in the single segment it gives me the direction of that segment as well as the length of that segment. Here if I select a curve, it gives me the delta value of the curve as well as the length value as well as the radius value. So I press escape. Then I go to multiple segment. That means we are getting all the segments in one go. So to do that I select multiple segment and I press add, and I select the alignment. Then you will see all the data is added at once for all the alignment segments. That is about multiple segment labeling. Then I go to point of intersection of my alignment. Then I press add. My station label style is station. I press add. Then I select this curve where my PI occurs. You can see my PI station appears here. If I press escape and select the label, this is where my PI station is. So it is, if I drag this label, it will be directing to that point. This PI means the connecting point or the meeting point of these tangents. So if you wish to add all the PI points at once, you go to multiple point of intersection, and I go to add, and once I select the alignment, I will see all the PI points are marked on the alignment. So that is how to add custom labels on your alignment. So if you wish, you can modify these labels and add various data to your alignment. So these are basic things you can add. You can add more than these data to these alignments. So that will be another part of alignment labeling to learn that, but we will not be covering all those things in this course. These are basic things you can learn from alignment labeling. So you have completed the part of custom labels for Civil 3D alignments. Hi, in this video I am going to tell you how to add alignment label sets, because in alignments you cannot manually add alignment labels to every station. So in road design or any alignment used project, the alignment would be labels in certain stations that are, say, 10-meter interval or 20-meter interval, 25 feet, 30 feet, 50 feet. Likewise, you have to add alignment labels in certain intervals. So in that case, Civil 3D uses something called alignment label sets, so that you can add set of labels directly to the alignment in a predefined interval. To do that, I click this alignment and I right click and go to edit alignment labels. Edit alignment labels. So there are several ways to add alignment labels. Here you can add several label sets. Here the type is major stations, and major station label style is perpendicular with tick. So to add this label style to your alignment, you have to click this add button, and I click OK to see how it works. You can see the alignment labels are perpendicular to the alignment. They are at 20-meter interval. You can see like here. So now, how do I know these alignment labels are sitting at 20-meter interval? That is a problem. So that is given at the alignment label window. This edit alignment label window, if you change this increment value, currently it is 20-meter increment. So if you change this increment to 25, this would be at 25-meter interval. If you change this to 10 meter, this would be at 10-meter intervals. So I change it again to 20-meter interval. Then I can add certain other alignment types. Minor stations. For minor stations, it will only give a tick. We add that one and click apply to see what happens. That means they are adding at 10-meter intervals. It will be only giving a tick mark here at minor stations. So when you are getting experience with these alignments, you know from 0 this is 20 and this is at 10-meter intervals. That is how it happens. If you have a doubt what is the interval, you can go to edit alignment labels window like this and see what is the increment. If you want to change this minor label increment, you can change it like that. Then I click OK. I have major station labels and minor station labels. Then I like to know the labels at these geometry points, or the places where my straight section changes to curve, or my curve section changes to straight section. So that can be done by adding geometry points. I select the alignment and go to alignment labels, edit alignment labels, and I am going to add geometry points, and then again I add it. Then it is asking what are the geometry points you have to select. So you can select alignment beginning, alignment end, so many points you can read, and you can uncheck the data what do you don't want. So I accept all these things to be appear in my alignment. Click OK. Then again I click OK. You will see my curve start station label. We have a label on the midpoint of the curve and label at the end point of the curve. So another problem appears here. So do we need every time, every time when you are going to label the alignment, do we need to add this everything one by one, adding major stations, then adding minor stations, and then adding geometry stations? It is a bit tedious process adding one by one. In that case, the alignment label sets make a handy option. That means there are pre-configured, pre-saved alignment label sets, something like a collection of these label set. That means major station, minor station, and geometry points. There are a set of alignment labels pre-configured in Civil 3D. They are called alignment label sets. So they are used to get quicker alignment labels for the alignment. This is how to do that one. I click the alignment, then I right click and edit alignment label set. Then I can create import label set. Before importing label set, I am going to save my configuration as a label set. I click here, save label set, and it is asking for a name for my label set. I will save it as new alignment label set. It is showing what are the alignment label sets appearing under my alignment label set. So if you need to modify it, you can modify it. Otherwise, you can click OK. Now I click OK. Nothing will be happen. What I have done is only saving the alignment label set. Then I again click the alignment and right click, go to edit alignment labels, and this time I go here, import label set. I click here. Then it shows me what are the label sets currently appear. If you don't want to see any labels from the alignment, you can select no labels. You click OK and you can see no labels here. If you apply, these labels would be no longer here. Everything would be disappeared. So if you select something like all labels, it will be populated with so many labels. If you click apply, you will see so many labels here. If you select alignment major and minor only, another label set will be appeared. If you import your own label set which we saved as new alignment label set, that will be also appeared. So once you get the required one, you can click OK. For the moment, finally I will select major and minor geometry points and click OK. This will be appeared. Still you can change this, increment this of these label sets, and I click OK. Now my label set, final label set appears like this. So in your actual project, you can use your desired label style, or you can create your own label set according to your needs. So that is how to add and edit alignment label sets. Hi, in this video we are going to learn how to create a report from alignment. I have an alignment here in this drawing, so I am going to create a report from this alignment so that it contains several alignment data in this alignment. So these data can be used for reporting purpose, or otherwise these can be used as setting out data to set out this alignment on site. So to create the report from alignment, I have to go to Toolbox tab here. You have Prospector, Settings, Survey and Toolbox tab. So if you can't find Toolbox tab here, you have to click this one, this button. So if it is not appearing here, you have to click this button so that it appears. In this toolbox, you have to go to Report Manager. We are dealing with alignments, so we have to expand that alignment. First, I will create a PI station report where the alignment PI stations are consist of. To do that, I select PI station report, then I right click and then I go to execute it. So it gives me the available alignments in this drawing. Only we have one alignment, that is alignment 2. So we can specify what is start and what is end station for this alignment. For the moment we are dealing with the default start and end station. So I click create report. So XML or HTML document will be displayed. It will be open through your Windows Internet Explorer, or maybe it might be open with your Google Chrome. So it has the PI station data. This is PI station, the northing easting values of the station and direction of that station and distance from the alignment. These data can be found here. So these data can be used to recreate the alignment if the alignment is not available with us. If we send this data to some other person, he can create our alignment using this data plus some other data we provide. So instead of keeping this as HTML file, we can use this data to copy to a Excel sheet so that we can get more user friendly data. To do that, I right click here, then I press select all, then again I right click and say copy. Then I move into Excel and open Excel and open a blank sheet of Excel. Now I have opened a blank sheet of Excel. Then I paste my data into this. So I have this data pasted into my Excel sheet. I can use my Excel knowledge to use this in a more readable manner. So you can do these things as you wish to get a more readable drawing. So then you can save this and give it to a person who needs this for setting out purpose or some other purpose according to his or her need. So this is how to create an PI stationing report from alignment data. Another thing we can do is I press done to end this command. Another thing we can do is create alignment curve report, this one. To create that report, I right click that and go to execute. Then since we have only one alignment, I will press OK. If you have more than one alignment, you have to uncheck all these things first and check the required alignment only. So I selected my required alignment, then I press OK. And it is asking for a place to save this HTML report. I accept the default place and press OK to overwrite. Then it is giving me another report in HTML version where you have the alignment curve data. Here you have the tangent data, then spiral or curve data, everything we have here. So these data can also be used for reporting purpose as well as setting out data purpose. So this one can also be saved in an Excel sheet as we have done before, and I will not do that part because I have done that once in the earlier PI station report creation. Then I will move on to next report creation method, that is incremental stationing report. I right click and go to execute. Then it is giving me the available alignments. Only I have this alignment. You can select what is the end and start stations for this report, and in this case I will set my station increments to 5 meters. So I will be having a station data at every 5-meter interval. So I create report with pressing that button. So I will get this data in 5-meter interval. You can see 0, 5, 10 likewise. Then at each point these are the coordinates and the direction at each point. You can see these data in the alignment incremental station report. So that is how to create alignment reports. Also there are some other reports you can give a try and see what they are. So that is about creating reports from alignment that can be used for reporting purpose as well as setting out purpose.
In this video, we are going to look at how to add spirals in Civil 3D. This is a series video. In the first video, I will tell you how to add a single spiral. That means we are adding only one spiral. Here I have a curve. So I am going to add a spiral to this curve with a line. That means I am going here. You have two options, floating line with spiral. So we are going to have a spiral with a line. So we have two options, through point and length. This through point and length means the length of line. So you can, if you know the length of the line, you can give the length. If you don't know the length of the line, you can use through point. So it will be better to use this through point option. That one is very easy to handle. So I will go with through point option, but you can use spiral option with length also. So I click here. So it is asking me select an entity to attach to. So I am going to add this spiral to this one. So my alignment is going from this side to this side. So it is asking what is my spiral length. Usually this spiral length is coming from a geometric design guideline. So depending on the speed of the road or speed of the alignment, it will give the spiral length. In my case, I will give a value as 30 here. My spiral length is 30. So it is asking then what is your through point. You can see when you are having this line through point, we have a tangent line and a spiral. This green color area means the spiral. It will have a 30-meter length. So I will click somewhere here and right click. So now I have a curve and a spiral curve and a tangent section. So if I turn on the labels here, you can see here 136.73, 166.73. That means this is a 30-meter length spiral. So that is how to add a spiral to a curve with a floating line. Then we will see how to add a spiral to a line with after a line with a curve. So you have to go with this option. I use this drop down and I will add this one here, floating curve with spiral. This time also you have two options, length and through point. It is same like the earlier version. So here you will have a curve with a spiral starting from an entity. That means in this case it starts from this line, and if you need to know the radius of the curve you have to add, and you need to know the spiral length also. So I will go with this through point option. I click here and this is asking me whether we are to attach this one. I will attach this to this entity. So it is asking radius of the curve. Let us say the radius of the curve is 60 meters. Then it is asking what is the spiral length. So in here also you have to get this value from a design guideline, but I will type some value here as 25. So it is asking whether your curve is going is greater than or less than 180. That means whether your curve is going like this or going like this. Most of the cases we are getting less than 180 option, so I will accept less than 180 option and press enter. So now it is asking where is my through point. So I can click anywhere in my screen according to my requirement to get this, and you have to right click to end the command. Then here also you can see my 25 meter spiral is added, and also if you see this radius here, it is 60 meters and spiral length is 25. So that is how to add a simple spiral or single spiral to a curve or a line in Civil 3D. In the next video we will see how to add reverse spirals and compound spirals into Civil 3D alignments.
Video I have this alignment, so I will be using Civil 3D 2022 new features, free reverse spiral, curve spiral option, and two other options listed here. So first I will use this one. So to get that one, I go here and I go to this option, free reverse spiral, curve spiral from option. So I click this one. So it is asking for to select the first entity. I will select this one. Then it is asking to select the second entity or the next entity. I will select this one. So it is asking whether our solution is less than or greater than 180. It should be less than 180, and it is asking for the radius of the resulting curve, resulting reverse curve. I will type it as 150. Then it is asking for the spiral in length. So this one, the spiral with this curve, so I will type it as 15 meters. So this spiral length should be given by the design guidelines, so you have to use correct spiral length according to the design guidelines. So I will select just randomly 15 meter length. Then it is asking for the spiral 1 out length. I will select that one as also 15, and spiral 2 out length also as 15. So you can see you have a nice looking curve with a spiral between this tangent and curve. Then I will move to this option. We have a curve and a straight. In between I will have a reverse curve with spirals. So I will move to this option, free reverse spiral curve spiral. So I select this one and I select this curve, and I select this next entity as this straight, and my curve solution is less than 180. My radius again I type it as 150, and for the spiral length I will type it as 15 as earlier. So then you can see again I created another curve with spirals
even though this is small, you can, according to the parameters, you may have a higher length curve if you adopt the correct parameters according to the alignments. Now in the next part we will move on to this one. We have two curves, and we connect these two curves with a reverse curve in between with spirals at the edges. So I will select this option and go to free reverse spiral, spiral, curve, spiral and spiral between two curves. I select this option. So the arm of my first entity is this one, next entity is this one, and curve solution less than 180. Again I will type my radius as 150, and spiral 1 in length I will type it as 15, 2 in length I will type it as 15, and out length also type it as 15. So it will give me a nice looking reverse curve with spirals between these two curves. So that is how to use advanced or new Civil 3D 2022 reverse curve options.